dead, you poor thing. Damn, girl, what the fuck's going on? Is it because my droplet's too small? Maybe. Can't handle all the juice, bro. Well, she's not sitting on my P3, so I'm not gonna move her. Sounds like effort. Twitch. Let's go here. I'll probably just like listen by myself. Use my own bandwidth. Cringe. Okay, so then if Arc will fucking work, what do you know? During the prelim round of the Nationals. Okay, well. Okay, well. Alright, Alex, I'll restream your thing. That sounds far more engaging. Oh, she died. Poor girl. I wonder what happened. Let's see, did the droplet go down? Poor girl. I wonder if the built-in, if it's installed. Okay. Hopefully that's fine. Conda activate space. Okay. So I have a Conda environment there. Okay, so what I will do, so I will restream this. I'm gonna say restream plus cannons and cans in the background. Okay, yeah, I want to watch that instead. So let's figure out how we're gonna do that. What we're gonna do, I think, well, we're gonna go over here first. Just double check the volume. What we're gonna, okay, yeah, volume's good. Let's test. Okay, yep, that works too. And then, so now I can take my browser and I can not leak all of my AWS information everywhere, because that would be bad. But what I can do is change the window capture over to this thing. And then what we're gonna do is we're gonna go to Twitter. And then we're gonna watch Alex's little friend here, little thing.
You get this asterisk radar sensor message, and then the industry has built a couple of decoders, and this allows you to track airplanes. This is like a flight to into Barcelona. But the way that it works on the back end is that you get this message,
okay, I'm gonna
and
try
then there's in
get
this
my
case
there's
an asterisk PDF that explains to you when you get this message, how do you decode it, and then what you need is you need to put it into parsable JSON format. That's the first step, and on top of that, and that's basically the core building block for decoder here. And so, yeah, what we did is we basically took this PDF, did an OCR, and then passed it to the LLM to create the schema, and the output is a parsable JSON format that can be then a core building block for decoding. And let's jump into the demo.
Let's.
All right.
Sounds really interesting.
So the demo is pretty straightforward. You select a file here. This cat001 is basically this open source standard for this radar system, which has a bunch of these standard data items that need to be extracted and transformed into the JSON schema that you're showing you. So let me just run this. So you upload the file and then you hit run extraction, and then that kicks off the agent. So the first thing the agent will do is find which pages all these standard data items are on. So here it's showing here all these standard data items, and then it's spitting out JSON, a structured JSON schema that an engineer at the DoD can use basically to build a decoder for these messages that are coming in binary. Yep,
Wow.
that's it.
Very cool.
And so here in this case, we actually have a benchmark because it's open source, and some other people have built a JSON schemata that we can benchmark it against. But the reality is that in the defense industry, a lot of it is like private, and so nobody's actually building those standards or those JSON.
So what can I do with this JSON here? So I have.
Next step would be that you basically get the message and you can build a decoder on top of it, right? You get the message and then you can.
Yeah, so you can use this open source library. It's called it's just called Asterisks, but basically there's a GitHub repo here where my internet's being slow. But basically, there's a GitHub repo with a decoder that this person built, and then it generates you can generate hex data based on the schema that we showed you, and then decode it into like actual human readable messages.
And basically tracking flights, longitude, latitude, altitude, speed, and basically have surveillance data, air traffic surveillance data.
Very cool. All right, awesome, guys. Very cool. What's the project name again?
Apollo.
Apollo. Awesome. Good work. Good work.
Thanks.
Oh, great. Good hiking there.
So,
Hey, go little hacker here.
okay, that's fine.
Did you put something like this on Twitter recently? Nope.
Have you guys finished judging yet? Is this your project? Did you guys finish judging? 2 rounds?
Yeah, we got both. We did both.
Awesome. And I'm streaming to almost 400 people right now. You guys want to check it out?
Hell yeah.
Hello.
Hell yeah.
Yeah.
What's up?
Likewise. What's Hyperion's Wrath?
Damn, that's a cool fucking name, bro.
We're levitating a microprism using these.
Can you speak up just a little bit?
Yeah, absolutely. We are levitating a microprism using these microtransducers. And this allows us to, when we shine a laser beam through, which represents enemy communications, it allows us to split off some of these communications, letting us basically snip on their communications without letting them know that we are indeed intercepting their communications. Application is satellite to satellite communication, ground to satellite, as well as drone to drone. So that's what we got.
Wait, so what's going on here? You have some levitating.
We can levitate a piece of material in the air and then refract some lasers off of it.
Wait, what the fuck? That's cool as shit. Okay, so now.
And so, what is the refraction supposed to accomplish?
Just all sorts of random shit. I mean, it's not
Based. I fucking love these guys, bro.
Wait, so break it down to someone who knows nothing about lasers or communications. So,
Hell yeah, we're in.
how are you disrupting the communications here?
Yeah, those are more details that we can talk and further depth.
For what?
Those are details we can chat more.
Yeah. Yeah. Well, what's the TLDR? To a layperson, suppose they're 500,000 people will probably watch this. Explain this to somebody who does not understand. They're just randos on Twitter who are vaguely interested in tech.
We can move things in space.
Okay.
That's really the TLDR.
Okay, so you're levitating something, right? And now you're shining a laser on it. And what does that accomplish?
I'm gonna sign an NDA for that one.
Yeah. Okay. So what do you think the judges will ask?
We got 400 people online that we don't know about. And this is a defense act.
Yeah.
You understand?
No, it's this is I'm working with Cerebral Valley, just FYI. I'm one of the media team. So
It's just more like some of the stuff is
got it. Okay, so you don't want to divulge the application of this because
from people that we work with
cool.
users at Uncle Sam.
Gotcha. All right.
We're doing this out of policy compliance.
Pretty
All right.
fucking cool
Sweet.
though.
400 people who's on there. I mean, do you want to be liable for that?
Look, I mean, the whole idea behind this is like it's a public hackathon, so I wouldn't ask you to share things that are undisclosed.
I'm not trying to be.
But
I'm not trying to be
no, I know, but that's kind of the assumption. But cool. Looks interesting. Are you gonna? Does it actually work? Like, do you need to plug it into a socket? No, I mean like, it's like, yeah.
Unfortunately, one of our chips this morning, which is
Yeah.
just wonderful. Not before
Gotcha.
we record the demo, but Buy American, everyone.
All right. Awesome. Good job, guys. Looks fun. All right. I think that's enough demoing for me. I'm gonna get lunch.
Oh, rip.
All right.
I was just getting started, Alex.
from
Fucking
Chapter
A, buddy.
2, Cerebral Valley.
Well, I guess I missed most of it. For context, I am fiddling around with like oil for a little bit to see if I can actually like figure out how the fuck this shit's supposed to work. But if I can, and I can successfully get into I can open a directory with edit path or oil float path. Okay, so oil. Open a directory with oil path. I do. Okay, but that's not what I want. Single directory. Maybe just because I don't really understand how oil works is probably the thing. Like, it looks like I'm SSHing in here, but I can't really tell that's actually happening, because then when I go to navigate anywhere, I feel like I've done this like once before. I haven't really figured out how to do it. So if that's the case, do I want to just, can I just copy my, I can copy my config folder over there, right? Maybe that's what I'll do. Okay.
All right.
Well, we'll
Sorry,
watch this for a little
120
bit.
people. We're
And
taking
then
some
we'll play
photos
with
here.
cans and stuff. So.
Are you one of the judges? How's it going?
All right, I'll let you guys. That was All right. Appreciate it.
Kind of fire.
Oh, we've been judged yet?
No, we got judged one round.
Cool. I'm live streaming to a bunch of people. You wanna? Can I get the quick rundown? 132 people want to see it. Sense and tell.
Yeah, so Sentinel. So we're making cheap, low-cost auditory and other sensors that can be dropped by drone or brought on a plane or whatever. Land and communicate back to the mothership wherever that is. Basically solving like a problem of like not enough information in the battlefield, or at least more information is better than less information sharing. So intelligence, surveillance, reconnaissance type ops, and if you don't have your capability to get like military grade hardware, you can make it damn near close with all the sensors. So that's kind of the problem we were tackling, was like how would you make your own sensors if you didn't have access to military grade unmanned ground sensors. And then once you have your sensors, you kind of want to plan like placement of those sensers. So we kind of made a tool that you could use to map out like your ideal sensor location based on your area of interest. So if this town's forest is like an area of interest, we can kind of map it out and then get ideal locations, placed for our drone to deliver our sensors.
So it is like you have a drone drop these boxes.
Yeah, basically these are like in little cases, like, this is a Raspberry Pi, but you can imagine a similar type case, drops it, has a battery that lasts for like a year, and just makes a little snail trail for communicating back to where you actually have reasonable calls.
And how does this connect? Like how does this like Starlink or like I don't know.
So there's a few different radio like chips on here. The one I'm a big fan of is LoRa radio. So that's long range radio frequency bands operating like 800 and 900 megahertz. With in uncontested airspace where there's not a lot of jamming, you can easily line of sight it 10 kilometers or more with less than 100 milliwatts. So it's really cheap. It just doesn't have a lot of bandwidth, so you can't send a lot of information. But with this type of chip, it's an ESP32. Is like the.
And what information is it sending exactly?
Right now, just it's classifying sound, and if it triggers.
So it sends sound. Okay.
It processes sound and then sends a boolean like, "Hey, I got triggered," and then it actually sends like the Fourier transform of the sound. It doesn't send the pure sound. That'd be too much bandwidth. So it does some processing on the edge and then sends a signal back. That signal gets kind of displayed in a Grafana dashboard, which is just an open source tool for displaying time series data, location data, etc. We run some anomaly detections, and
If there's like an anomaly, then like this map would turn red, and like you could like zoom in and click on that and see what sensor was stripped.
yeah, it's color coded based on the status of the sensor. Use a bunch of open source software and put together the hardware here on site. This is pretty much plug and play. There's some soldering required to get your little headers in, but everything else is pretty straightforward.
Very cool.
And under
10 to 20 US dollars.
yeah, exactly, under $20. So you could easily imagine making a bunch of these.
Awesome. Cool. It's the Sense and Tell. Rad. Good job. Very cool project, guys. Hello. I'm live streaming to 176 people on Twitter right now. Can I get the quick rundown?
Yes, it's a strategic value visualizer. It goes a region, resources, gives you a threat analysis of like what should be post risk or reverse scenario what you should be attacking first.
Right, so what's going on here? We're bombing Mumbai or something?
No, this is more like we'd be telling Mumbai where their hotspots are for a potential attack and how they can prepare themselves from any adversarial forces.
So how does it work?
So we basically we use a couple data sets. I mean, the main ones are just like kind of the OpenAI knowledge base embedded in ChatGPT, and then the other one's the Google Maps API. And so we're pulling in, kind of rail stations, ports, airports, major bridges, refineries, anything that kind of has some kind of strategic significance from a mainly like logistics, industrial perspective. And then we will generate a heat map based on kind of proximity to these different strategic locations and kind of, how important it might be to like hold that land.
So we have like some data centers here, and then like Long Beach Airport, right? So what are these gray squares, gray circles supposed to be?
That's like the color coded kind of any circle that's on the map is like signifying it's kind of close to a large collection of strategic resources or locations. And it's a little bit hard to tell without zooming in more, but as you get closer to these locations, the color kind of gets more red.
Can you zoom in, or will that break the demo?
Yeah, no, that'll work. Let's see here. So you can see here, we kind of have a hot spot in this area, for example.
Wow. And the idea here is, what can you do with this information?
I think, in America's case, I think there's an increasing concern about attacks on infrastructure. So I think this gives a quick visualization, given a city, like where might the critical infrastructure be? And kind of, could be used as like an aid for wargaming kind of use cases, maybe.
Super cool. What's it called again? Strategic Value Visualizer?
Yes, that's it's a first iteration.
Very straightforward. I like it. Very cool. Awesome work, guys.
Thank you.
Yep. Hello.
Hi.
Are you a team?
Yes,
I'm not
we are.
judging, but I'm streaming to 200 people on Twitter right now.
Okay.
Would love to see the demo.
We worked on doing open vocabulary detections on satellite imagery.
Could you speak up a little bit? Sorry, it's
Yeah.
kind of noisy.
We did open vocabulary detections on satellite imagery, and then built out some semantic search across a social media data set. The value prop that we were kind of looking at was I previously worked with the CIA doing knowledge transfer for analysts, and when an analyst rotates out of a position, they take all of that knowledge with them. So we worked on solving the problem of how do you retain knowledge when someone cycles out and decrease the lead time that it takes for someone else to fill in the place. The thing that we were interested in within that problem space was vision language models and how we could use that in order to make the absolute ridiculous amount of imagery data that we have more useful to analysts. And so that was broadly what we were focused on, was just vision language models. So the first thing we did was doing visual question answering on satellite imagery, but you can use the same approach for any type of imagery data, extracting specific features that are kind of open vocabulary, so you don't have to train a model to.
What is this we're looking at?
This is satellite imagery from, I think it's in Brazil. Yeah, from Skyfi.
What is that orange thing?
These are ships, and then it's a little hard to see, but there's like bounding boxes on top of these like cargo ships that are automatic detections with that. So we just use open source models like Owlbit to do the detections, which is an open vocabulary detector, so it's trained on the entire internet.
So you take satellite imagery, and then you run these classifiers on it, and you're able to do what exactly with that?
So we were largely looking at building out dashboards, giving it the data source for imagery, generate automated analytics that you can pull directly out of it without a human input. So previously with these types of approaches, if you wanted to extract information from imagery data, you'd have to train a model, which would take engineers and time and data sets to do all that stuff. You can now use open source models that require no fine tuning to get like 80-90% of the same performance.
Cool.
Yeah, so we started here just doing like feature extraction. The other piece of this that we were doing was differencing between like points in time in the same year. So given like two images of the same scene, determine whether there's been change in like facility structure, density of people, or anything like that. So again, that's just like the image transfer. These were some other detections. So flooding detection, so natural disaster identification and identifying where like are the main areas of problems. And then that sort of led into the semantic search work that we did, which was building out like a whole semantic search across a social media data set where you can query for information from the actual social media posts together.
So what do you? So where are we looking at now? Twitter or?
Yeah, these
blog?
Largely from Twitter and Telegram. And then we index all of the posts and the images within like a PG vector database. And so you can put in a prompt as if you're searching like Google and get back relevant imagery or relevant text information.
Very cool. What's the dashboard look like?
It's just a Streamlit app.
It's just, yeah, I mean that's cool. I mean, Streamlit's great.
Yeah.
Nothing wrong with it. All right.
Search box.
So what do you search for?
We did
Helicopter. A little slow because we're
super slow. Everything we did is run locally.
Yeah, no worries.
It's CPU.
So it will basically find helicopters in the posts and then.
Either instances of helicopter like in text or actual images.
Oh, I won't look at the error.
Connection is just down.
It's all good. Live demos. Very cool. What's the name called?
We're Team Prothos. It's not a... Yeah.
Nice. Awesome work. Congratulations.
Yes, exactly. So like for example, like internal military incidents, crime, social problems, and things like that.
Hello. Have you finished judging yet?
I haven't even had a single one yet.
Okay, cool. There are 268 people on the live stream right now.
Excellent.
You want to give a quick rundown?
Perfect.
Of
So,
Morph?
Yeah, Morph. So basically looked at a bunch of DoD documents. They said that they have a need for wearable technology and software to understand biometrics.
Wearables.
Wearable devices. So basically what I was able to do very shortly, and I'll kind of go through here. Here's kind of like the sources behind my thing. Go find public Aura Ring data.
Aura Ring, like the...
commercial off the shelf, right?
Gotcha.
So we're not going to do anything special, not going to have to make them, build something new. They are kind of doing that, but it's funny. The problems that actually talks about consumer off-the-shelf wearables as well.
Super cool.
Use that data and use algorithms, right, LLMs, to see, okay, what's actually going on with that data and how can we turn it into actual insights. An example of this where it can be used now is in the Philippines. So on April 22nd, they actually shipped around 16,000 soldiers to the Philippines to do military exercises. So they're going to be doing drills like, you see them running on the beach, shooting javelins, right? So they're kind of exerting themselves, but they don't necessarily have the care and understanding to know like what's going on. So the tool here, you can come here and say, okay, you have some statistics, so these are across the population, like the sleep scores, time that everyone was asleep, things like that. Daily sleep scores here. You could also ask it questions, right? So if you're like, okay, what is or who is that? Is there anyone at risk in the group or something like that, right?
Okay, I don't
Really? So it'll tell you, oh, there are 3 individuals here who have shown consistently high exertion, sleep, and stress levels. We got my boy John Doe. De-identified information, right? But John Doe, you can see the profile, and then it has like data about John Doe.
Wow.
You could even do like environmental stuff. So let's say like, are there environmental issues that could come up? I don't know. Cool. So then this will basically give you, and I hard-coded the location in there, like the weather data. But based on like the air quality index, the UV index, the temperature, you can be like, hey, it's high, and this is also artificial UV index, but it's high. And so it can cause increased physiological strain, and these individuals here with this data are of a high probability of having strain based on what we know about them. You could also do like population-wide things, right? So like, how's the recovery of the group? Boom. And so you can be like, okay, the recovery here, everything was lower this week compared to last week. You can see the best, the worst, and now the operators can kind of understand like what's going on across the population. So it's easier. If we go back to the doc send, right? Another thing that is possible here is not just having it as a standalone tool, but you can integrate it with existing tools. So one of the things that they were doing actually on Palantir, they have this thing called AIP, which is like a way to make decisions. It was this group of, I think, it was either like a tank or some people that they were mobilizing troops up, so they wanted to strike them. So they had these different like courses of action. I'll zoom in here so you can see it. These different courses of actions to eliminate the threat, right? Target with an air asset, target with long-range artillery, or send in the tactical team. In the video, they actually sent in the tactical team, but the thing is, up at the chain of command, they don't actually know how the tactical team is doing like physically, right? They could not be good, they could be overly stressed, and that data could affect, right, what this person decides to do. So what we could do is take this exact same like software framework, this same stuff, and kind of just plug it into existing tools that they're using to give the the people doing whatever they're doing the best decisions to make the best to help the country.
Wow.
Yeah. Stumbled there at the end.
You're making like smart soldiers using aura rings and consumer tech. That is so cool.
I would love to say that I came up with the idea, but I'm not gonna lie. They just said.
They said it in the prompts.
Yeah, they said it in the prompts, right? It has great potential that has not been fully realized, right?
I mean, I can't think of a better way to validate an idea than telling you that. This is super cool. Wow. Awesome. What's the project called? Morph. Why is it Morph?
I just think it's cool. Right? Like,
Based.
It's one word. It sounds okay.
Oh, this is rad. All right, what's one big thing you learned while working on this project?
Yeah, I think the funny thing is this is not as hard as like LLMs are smarter than I thought in terms of like gathering this information. I thought I would have to do a lot of like manually plugging in information from PubMed, but it's very encouraging to see how the training is going. So you can just give it like raw HRV data, and it will be pretty accurate on like what's good and what's bad and detecting anomalies.
Wow.
So I was
Awesome.
impressed.
Very cool. Awesome project. Good job. Oh man, cool projects.
Here you can see that
Did we do it? Looks like we did it.
So what we're seeing here, I use this hardware device. So I have two devices.
Alright.
One device I have here is a Mac spoofer, but it's going to change MAC addresses. Okay? And it's going to set hardware. So you can use this to like, take.
Problem is, if I'm just copying files over there, I need to run them on that machine. So how does that work?
Over here, all I did
Because
is
that machine is the hardware I need.
and then I run my algorithm. This is the algorithm to determine if it's a spook.
And can I use the terminal from here?
Yeah.
I don't think I can, right?
This is actually working. This one is not. On the different type of it? Yeah, the different types of ones. It's like an omnidirectional antenna, and this one is one we use for actual drone detection. I just brought it to show, for like, hey, you put this outside.
So drones also have a license plate now, right?
Yeah. Oh wow.
You know that, right? They have ID. And you can find out if the drone is valid ID registered, because FAA, cities, everybody is trying to control.
Where's this at? Where's this at?
Okay, so I think it's actually best just to use Jupyter, but man, how do you do this?
We keep track of like the objects that.
What's up? You guys demoing? You done judging?
We got 2 judges come so far.
Cool.
I think we're supposed to get 2 more.
I think it's only 2. Yeah, I'm live streaming to 353 people right now. Yeah, you want to give a quick rundown?
You do, no, you do it.
Another business guy. All right. All right.
Well, I can show a demo after.
Cool.
Okay, so we're
Apollo.
It's the AI agent for ICDs. If you don't know what ICDs are, same. When we came here last week, or yesterday actually, we didn't know. But actually, in the defense industry, a lot of APIs are basically stuck in PDF hell. So basically, you've got these people, because it's national security concerns, they're basically not sharing an open source API so that different contractors can connect with each other. But basically, the way it works is
don't
you
know.
send a message,
It's just
somebody's decoding it by going through this long
look at the
15
usage
page
guide for
PDF
this.
and getting a let's say a hex or a binary message and decoding it manually. And so that's what we're solving. And we did it specifically for an open source a flight to into Barcelona. But the way that it works on the back end is that you get this message, and then there's
yeah, so I grabbed the
in this
NGC
case,
torch container, if I remember right.
There's an asterisk PDF that explains to you when you get this message, how do you decode it, and then what you need is you need to put it into parsable JSON format. That's the first step, and on top of that, and that's basically the core building block for a decoder here. And so, yeah, what we did is we basically took this PDF, did an OCR, and then passed it to the LLM to create the schema, and the output is a parsable JSON format that can be then a core building block for a decoder. And let's jump into the demo.
All right, demo time.
So the demo is pretty straightforward. You select a file here. This cat001 is basically this open source standard for this radar system, which has a bunch of these standard data items that need to be extracted and transformed into the JSON schema that you're showing you. So let me just run this. So you upload the file and then you hit run extraction, and then that kicks off the agent. So the first thing the agent will do is find which pages all these standard data items are on. So we're showing here all these standard data items, and then it's spitting out JSON, a structured JSON schema that an engineer at the DoD can use basically to build a decoder for these messages that are coming in binary. Yeah,
wow.
That's it.
Very cool.
And so here in this case, we actually have a benchmark because it's open source, and some other people have built a JSON schemata that we can benchmark it against. But the reality is that in the defense industry, a lot of it is like private, and so nobody's actually building those standards or those JSON.
So what can I do with this JSON here? So I have.
Next step would be that you basically get the message and you can build a decoder on top of it, right? You get the message and then you can.
Yes. So you can use this open source library. It's called it's just called asterisks, but basically there's a GitHub repo here where.
Yes, if I did a torch container.
My internet's being slow. Basically, there's a GitHub repo with a decoder that this person built, and then it generates. You can generate hex data based on the schema that we showed you, and then decode it into like actual human readable messages.
Yeah. And basically tracking flights, longitude, latitude, altitude, speed, and basically have surveillance data, air traffic surveillance data.
Very cool. All right, awesome, guys. Very cool. What's the project name again?
Apollo.
Apollo. Awesome. Good work. Good work.
Thanks.
Oh, great. Good hiking there.
Hey, got a little hacker here.
post something like this on Twitter recently?
Nope. Wow. Have you guys finished judging yet? Is this your project? Did you guys finish judging 2 rounds?
Yeah, we got both. We did both.
Awesome. And I'm streaming to almost 400 people right now. You guys want to check it out?
Hell yeah.
Hello. Yeah. Likewise. What's Hyperion's Wrath? What is this?
Okay. Well, I mean, that was a kind of a short one. I'm cool with that though. In the meantime, what I've been doing is fucking around with NVim. My brain's like not connecting the dots on exactly how to take my local NeoVim config and edit files over on the AMI such that I can do things like use the shell on the AMI and launch containers on the AMI, etc., etc. So right now I am sitting on the P3. I'm launching a torch container. And then what do I do is the question. I guess what I can... Oh, it's going to be really annoying though. Because I would prefer to have my preferred editing environment, obviously. But I just don't know if there's a way for me to like conveniently port that editing environment around to multiple machines. So the method I was going for was with oil.mvim, but I'm not that good at oil, and oil, as far as I can tell, like, sure, cool, it lets me edit files over there, but like, what if I want to do stuff like run the files that I've edited over there? Can I run them over on that machine with oil? I don't know. Because I couldn't figure out how to open, or like when I would open a terminal the way I would normally do it. The normal workflow is I just do like liter ft, and then I run my command and I'm done, or I make a tmux pane for it. Which I guess I could do. Could I do that? Yeah, so if I make a tmux pane and I use tmux to SSH into the machine, well, if I'm working in a container in the machine, how does that work? Well, presumably I just mount the workspace file, right, to the container. Okay, so then I hop into that workspace file with oil, then I edit there, and I use my tmux pane to run stuff that I'm editing. Now the other problem I'm seeing is my LSP and linter and all this stuff that checks if my Python is configured correctly going to work if the machine on which I am editing from is not configured correctly, because it's not happening on that machine. My suspicion is no, but I guess it's worth a try. I'm also wondering if I even need to use this torch container or not. Like, best practices, presumably I should, but I don't know. Anyway. Well, I guess we'll throw that on screen for now, and then we can. Elon, I will never pay you your money. Stop trying. Stop asking, bro. Okay.
He will bring the prince to manhood and help him to destroy evil. Then what do you want of me? The evil warrior has sent a team of assassins led by Ninja Temple to kill the prince. You must stop them.
So I have if I have a Docker container up, I don't know how to get to the shell. You can do dev containers in what's Jibbity at, dude? There's the lady of him. Alright, we're gonna ask good old Jibbity here. Honestly, I hate GPT these days. Okay. Are you on 4? You have to be on 4, right? Interesting. Interesting input, Jippity. Okay, I'm gonna think about how to solve this problem. This is the... Alright. I'll be right back. One sec. Where did I put my music? God damn it. There it is. Okay, we back. Okay. Oh, I like this, actually. Let's try this. I don't know, I assume it's not this simple, but... That's the plan, if you can see it. Let's do it. Alex, did you start streaming again, bro? Okay, this is a great... Some interesting papers. Yeah, baby. God damn. We got a couple of cans. We got a couple of people mentioning that shit. Human preference. Why did you not make your... Okay, I'll just grab the repo, that's fine. Sorry, I'm distracted by Twitter as always. So one of the things, sorry, I was looking at Twitter and I got distracted, but let me swap over to show you why I'm distracted if there's a person watching this at all. Oh, it was on the whole time. Amazing. Okay. So let me so extra layers, copied even, no information was trained. The reason why Kolmogorov-Arnold is so interesting, I don't know if my assistant is going to be able to handle this. Maybe I can just keyword. Okay, there was a thing that I read when I was looking in to try and understand this thing. So the representations here, that, like, if in theory this can get scaled up to do like LLM stuff instead of just like the toy stuff that they did in this paper. There's a very interesting kind of feature that, so like, okay, so baseline premise is that, and also, yeah, I don't understand any of this fucking math, so I might be completely mistaken, but one of the draws of the can is that it is interpretable, and the reason it is interpretable is because the abstractions of the can layers are essentially like human readable, because the basic premise from my understanding is just like, here's these so like here's a representation of a proof of some kind. So it's if f is a multivariate continuous function on a bounded domain, then f can be written as a finite composition of continuous functions of a single variable in the binary operation of addition. So basically, you can decompose these like big complicated functions into something that is equivalent but smaller and makes sense. So what you can do with that is you can take any number of those representations in any combination and like basically get the corresponding level of quote-unquote zoom, because so if you have two instances of a representation, then you can position that as a multivariate continuous function, and then you can represent that as another representation, right? At least that's how my brain is thinking about it. But I did hear someone smarter than me say that you can effectively just like take part of a can, however large or small you want that part to be, isolate it and extract it, and then in theory transpose it somewhere else. So if this translates to LLM layers, which is kind of the thing we need to figure out, but if it does, then if what Eric has observed here, which is, hey, these things can actually like beat the performance of like modern models or modern like LLMs or AI as we think of them, through a matter of this kind of like repeated fine tuning. Like if we get enough LoRa's in the right kind of shape on the thing, then it gets really, really capable. So if you take that, like if that's the hypothesis, and then you take the other premise of, I can take any section of this model and transpose it, like isolate it, look at it, and then transpose it onto another model, then you kind of, what you end up with is this sort of like pattern of I can repeatedly take the best section out of any model and transpose it onto a new one until I get the model that has all of the best sections in order to perform this task, essentially, is kind of like how I'm thinking about it. But yeah, this is all like way, like I need to like do a lot more investigation into this sort of like architecture before I get too excited. But I'm very easily excited these days, so. But first things first, I need to get into a fucking Docker container, so let's do that. Fucking kidding me. There we go. Cool. Cool. We're in business. Am I gonna leak myself here? Just double check. I think we're okay. We'll throw this on screen so you can see. Just gonna clear this if I can. Okay, it looks like I can't. That's kind of annoying. It's fine. Okay, so let's see if we can start. Run my Vim server in the container. How do I need to structure Docker? Yeah.
In God's name, are you talking about? The son of the devil.
So if I'm in, so I SSH into the container, then I start it in local mode, so I'm good. I think I need to no-hub this. Cool. The listening server. Okay. I need to use a tool like NeoVim remotes.
God's name are you talking about? The son of the devil. You must die, Mr. Thor! The son of the devil.
Okay, let me look at this NeoVim remote package. Get up, please. Where? Hmm.
教頭先生に危害を加えることはこの鬼塚英吉22歳
Plan to be added back, you say? Are they added back now? Okay, so they are restored. The problem being, since NVR is a Python package, it's gonna get fucky real quick. God, I hate Python. Okay.
Perfect.
Okay. Fuck it. Shit. Okay. Getting a vent here. Just best practices wise, I'm suspecting it might fuck me up, but we'll see.
It was at this moment Jack
Yeah, hello? Oh, hey there, bro.
So the 8-6 and Kenta are battling in the rain, huh?
They sure are. You should see Kenta. His confidence is through the roof. But this is the 8-6. You have to be real careful and shift the car's weight while using precise timing. Otherwise, you'll lose control and find yourself wrapped around a tree.
Al was absolutely right. I was scared.
Although I should go check this out.
From the ringing of a telephone, picked it up, my nigga pushed it, told me that it's fucking on. Quickly took a shower, not an hour before I'm out the door. Time to school my niggas, then we run up in the liquor store. Slowly on a rapping from the ringing of a telephone, picked it up, my nigga pushed it, told me that it's fucking on. Quickly took a shower, not an hour before I'm out the door. Time to school my niggas, then we run up in the liquor store. Quick to make it, let it go. Quick to make it, let it go. Quick to make it, let it go. Testing all you brothers, cause I'm quick to make it, let it go. Pressing all you buzzers cause I'm quick to make it, let it go. We live in the fog, at the top, we do it every day. Started in the room, but now it's dropping, oh, we keeping hate. We talk on the mic, you know I'm hype because I'm on the dope. Testing all you buzzers cause I'm quick to make it, let it go. Ran into some problems with some niggas on the other side. Play me like a hoe and watch the unexpected killer ride. We just turn the script and run it out just like a bitch. But don't say fuck them buzzers as they kick it in the bitch. Now just like a 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 bitch. We just turn the switches, run it out just like a bitch. Slowly on a riding from the ringing of a telephone. Picked it up, my nigga pushed it, told me that it's fucking on. Quickly took a shower, not an hour before I'm out the door. Time to school my niggas, then we run up in the liquor store. Slowly on a riding from the ringing of a telephone. Picked it up, my nigga pushed it, told me that it's fucking on. Quickly took a shower, not an hour before I'm out the door. Time to school my niggas, then we run up in the liquor store. Quick to make it, let it go. Quick to make it, let it go. Quick to make it, let it go. Why? Because I'm on the dope. Quick to make it, let it go. Slowly on a riding from the ringing of a telephone. Picked it up, my nigga pushed it, told me that it's fucking on. Quickly took a shower, not an hour before I'm out the door. Time to school my niggas, then we run up in the liquor store. Slowly on a riding from the ringing of a telephone. Picked it up, my nigga pushed it, told me that it's fucking on. Quickly took a shower, not an hour before I'm out the door. Time to school my niggas, then we run up in the liquor store. Quick to make it, let it go. Quick to make it, let it go. Quick to make it, let it go. Pressing all you buzzers cause I'm quick to make it, let it go.
Sorry, I keep getting distracted by things. So we have any of them running there. So let's I'm just like blindly running these commands. Okay, so let's Q. So username at remote host, so it should be Ubuntu at. I suspect like this is wrong, honestly. Well, sorry for anybody who was hoping to see some models getting fucking trained instead of me playing with Yield and more. My bad. Bump bump. But I do need to like learn how to do this. My local machine. Okay, got it. Local NVR to connect to the remote. Okay. And then let's do. Oh, fuck. Did we fucking do it? Fuck me. Oh, wait a second. Can I do... Let me quit all this crap. And then PWD.
But now, I have a request to ask. I hope you'll take my body back to my home village for burial, so that my old mother and all my other relatives can mourn me properly.
Okay. What if I do, can I do terminal? I kind of suspect that this whole fucking thing has been like a big hallucination, but okay, so what if I do? Yeah. Okay, so what I should do, because I don't think I have the container port mapped correctly. Okay, so I'm gonna need to Docker kill.
Bringing it to you like this.
Docker kill confident Westhoff. Docker remove.
That fucking shit.
Do I want to? Because I don't want to re-download this thing. Fuck it, I don't care. DP4
like this.
4,000, 4,000. I wonder if I'm like doing this like in an unnecessarily complicated way. I feel like I am. Dun, dun. Okay, so now just run this just for fun. Check in on chat, see if there's any chat. Nope, there's no chat. LOL. Okay. Okay, nothing listening, which is fine right now, I think. Because what I'm gonna need to do is run this. That's what I thought. Okay, so I think I can just apt install it, right? Yeah, no, I need to do this crap. Oh my god, how fucking annoying. I don't like bothered cocktail peanut on Twitter. There's a thing I've been working on in my other window. I want to run a public instance of Pinocchio just so I can fucking let everybody burn through my AWS credits doing cool AI shit. But from the looks of it, Pinocchio is like basically impossible to run in a secure manner. But then I remember like looking at the docs and like Cocktail Peanut having this whole fucking weird shit where he wants like a network of LLMs or something. So presumably it's built so it can be part of a network, but I don't see how you're supposed to do that without like handing over the keys to the castle, you know what I mean? And I kind of want to like bug him on Twitter and fucking see what the deal is. Okay. So I port forward from my local machine, but that should already be running, right? Because it's tunneled. So I can use local. But don't I need to, yeah, so. Right, I need to listen.
Right here.
Really? Oh yeah, I need to finish fucking installing the thing. Okay, so what do you mean, you little shit? Oh yeah. Once again, I forget. Now I should be able to do the thing, right? No, because I added. No, I need to source the bash receipt. Now I should be able to do this. Cool. And then my net stat should work. There we go. Okay, so we're listening. Fuck. Because... Okay, so now we want to nvim dash headless. We're no hub first, no hub. Nvim dash headless dash listen. Yeah, probably spending this time figuring out how the fuck oil works would probably be a good idea, but you know, I don't like to be efficient. My music is gone. I'm crying. I'm crying and shitting. Let's see. So for this one I basically just don't care about if it gets muted, basically. So I'm just gonna listen to whatever I want, which is fun. Let's do this. I like that chord progression. Or I like that chord resolution, I should say. It's that last one right there. This one right there. Tickles me right in the brain. Okay. So... Gonna be NVR, I think. Look at this. This might be a question for Claude, actually. I am kind of getting what people are saying about Jippity being kind of an idiot right now. Like, Claude has decent Thankfully, I can still use Claude in the playground. I canceled my big Claude subscription because I was pissed at him. But I'm kind of leaning towards okay. Okay, so yeah, so I want to listen on 4,000, presumably. Okay, I think that's starting to make sense to me. So let's listen on 4,000. Bum, 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 bum. And then I should have the tunnel already set up. Okay, if I have tunnel set up locally, should I NVR? Okay. Okay. Let's see. SSH tunnel is set up already. Hopefully. Okay, and so now when I'm at home, I should. What was this? Can't connect. Echo. Okay. Where is my machine? Right there. This will be cool. Okay. Okay. What's going on? I'm presuming. Okay, could not request local forwarding. And then okay, well no, I think that's fine. PS aux though? Let's double check. Well, hopefully everyone's learning something about networking, if there is even anyone watching. But I don't know. I don't really check that these days. Let's look at chat. Chat's cool. Let's look at restream chat. Just see if I've missed anything. Nothing on lit Twitch. Nothing on lit YouTube, presumably. Yes. Figures, make sure. Okay, so let's just double check. Let's do Q. Okay, yeah, I'm suspecting. I wish he would have gotten a little more straight to the point. I am starting to see it now. The main issue that I have right now with Claude is that the primary coding assistant utility I use is Aider, and Aider works best in UDIF format for GPT, but when you run it with Claude, it doesn't run in UDIF format. It's search replace, and so I have to like wrangle him into doing search replace blocks, and he won't usually. So really what I need to do is just like push a fix to Aider that makes Claude do the same thing as GPT. Which should be pretty trivial, I think, but yes, so I am suspecting at this point that it is my security group that's fucking with shit. So let's fix that. bum 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 bum. Allows traffic on 4,000. So let's change this inbound rules. We want to change inbound rules, and we want to, let's go over here, security group. I'm gonna edit our inbound rules, and we're gonna add a rule. So my ACL should be inbound and outbound from 4,000. That's goofy. Do I need TCP and UDP open? Or just TCP? I mean, I don't know. I guess we'll also add UDP for fun. Outbound rules. Protocol. Okay, so it can go anywhere. So outbound rules are fine. Should be fine at least. So now we can check the tunnel. Great. Got it. Okay. So kill 9272560. SSH-L 4000 localhost 4000 NF, and then we're gonna go back to the instance itself. Okay. Now I should be able to tell that, right? I am gonna go look and see if what's his frickin' name is streaming his thingy again. New infinite layers. What the fuck are you? Okay. Sure, let's Yeah, man, I had frickin' things I was gonna do for that guy. ACLs, okay. Let's check ACL. Which subnets? Which ones? US East, right? Yeah. All traffic. Rule number 100. Okay, so let's grab that. I need to restart the tunnel. Neovim might be closing the connection. Okay, that could be, that's worth doing, I think. Let's do that. Man. Server and client have to use the same address. Okay, well, so I know I can SSH into it. Is there a way to try to SSH directly into the container? No, I can SSH into the host machine. No, that's fine, I guess, maybe? I don't know. Man, boy, you feel real dumb these days, bro.
I see what it's saying. I have to find myself in all this. You don't have to say anything.
Well, what's the move then? we just work in a shitty little Jupiter container, I guess. We don't have any of our spicy NeoVim stuff, but that's fine. We'll make it work. I kind of hate that I have to use the quad playground, but it's fine. I do want to at least get this machine set up so that it is ready to do some experiments. So let me see. Is there a readme? Yeah, mvim readme. Maybe I just kickstart Endem. It's less stuff, but... Alright, so we have Git. Okay, we have all of those. Install ripgrep real quick. I am mnist, right? Joke's on you. You thought we were gonna play with some novel neural network architectures? We're gonna play with NeoVim. That's what we're gonna play with. Fuck you. Too much fun, bro. Alright, ripgrep's in. Clipboard tool. This is a groove. This is a bop. Oh yeah, I have a bunch of videos I need to publish today too. Maybe we'll work on that after we get bored of this. A nerd font. Sure.
could have anyone you want. Why would you wanna be with me? I'm nothing special. You could have anyone you want. Why would you wanna be with me? You know I'm nothing special. Be with whoever you want. I don't care. I don't wanna know. Don't tell me about your
Okay.
problems. You know I'm trying to solve them. Don't ask me for my help. Fix it yourself. She tried to call me yesterday, but I didn't pick up. 'Cause I don't got time. Don't have time.
Oh, cool. I moved all of them. Thank you. Bruh.
Do whatever you want. I don't care. Don't even tell me. I don't really wanna know. Don't ask me how my day's been. I just wanna be alone. Stop talking about your past. I don't wanna hear it. Just leave me alone. I don't care about myself, 'cause everyone's trying to hurt me. Jealous, just leave me alone. Jealous, just leave me alone. Just leave me alone. I just wanna be alone.
Well, I know I have Python, but oh, I wonder if I'm supposed to do like apt install Node.js. Maybe that's what I'm supposed to do, right? I mean, what am I doing on this machine? I'm not really doing a ton of Node stuff. I don't think I need to worry about that right now. I'm fine. Wait, am I even in the fucking Docker container? I am. Okay, cool. Should probably just install this. Apt install. Install kickstart. Configs R should be in config /nvim, but that's fine. Let's go back to root. Well, yeah, maybe it's... Okay. Now I see why people keep their fucking NeoVim config in a repo. I'm a big idiot. Okay, let's install that. Yeah. I think we're good. Update. Cool, cool, cool. Cool, cool, cool. Cool, cool, cool. Cool, 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 cool. Okay, that should be enough. That should be fine. Okay. So, let's actually do the thing we originally set out to do, which is find all of the fucking canned shit. Oh, did we just figure out an infinite compute sneaky thing? Yeah, I guess I should probably be using something like modal or something. So this has telescope by now. Realistically, I probably should. Website IP to this space, huh? Okay, I'm gonna grab water. 1 sec. Okay. I have a plan, boys. And that plan is to go find all the repos and clone all of them. Sorry, I'm fucking looking shit up. Rip. Okay, what am I streaming again? Fuck, I keep getting distracted. Right. Boom, 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 boom. Sorry, I had to go defend the good name of cryptocurrency in the Shogas server, and then talk about incentive structures elsewise, and check in. Okay, what was I fucking... Oh, yeah. So... Yeah, that's what I need to do. I need to go grab all the repos. Yannick. So... These... repos... Most basic way you can... Okay, let me... fix my music for one. Let's do, yeah, let me get my favorite, my classic, this guy. Okay, the most basic way you can learn a function is to first define a parameterization for them. B-spline, standard gradient-based methods, you evaluate the function on a point, calculate the distance, and minimize it. Okay, yeah, fucking, alright, so, repo number 1. I think I forked all of them. I'm gonna make sure they're all forked. Okay. So, number 1, used Fourier can. So, let me take a look at what this is. layer intended to be a substitution for linear and non-linear activation. I'm also going to need this paper up at the same time, probably with an assistant. Yeah. So, let me throw that open in Chrome real quick. And I guess I can throw, okay, I think, is it more educational? I don't know, doesn't matter. I don't think I can, publish this anyway. It's fine. Yeah, so einsum and einops, fusing operations, we can use trig tricks. Okay, cool. Alright, can you tell me about what this means in the context of the PDF we're looking at? It's an implementation I want to play with, but I suck at math. Instead of using spline coefficients, it uses 1D Fourier coefficients. Okay. Good enough for me. Let's fucking clone this bitch. I'm gonna fork it first, though. Cool. Number one. So, alright, I'll just read this aloud. The primary purpose of Fourier can is to serve as a replacement for the traditional linear layer, followed by nonlinear activation. By using Fourier coefficient, it aims to be more efficient and easier to optimize. Okay, can I... which sections of the paper should I look at to learn more about what this is changing in terms of the approach? Oh, wait, what the fuck? Wow, okay, so Copilot just, deleted everything it said. No, that's literally not at all what I wanted. Okay, so we're gonna have you do that again, and then we are going to use this. Running a custom op allow to not materialize memory. 0 extra memory needed. In addition, it also allows to do some trigonometric trick to compute the cosine of kx and then the sine of kx more efficiently. So let's look at that code. Oh god, this is C. Okay, I'm gonna be way out of my depth, but Can I make sense of this? Okay. So we get function, increment the value of out. Out should be initialized to 0 beforehand. Okay, so okay, can you explain based on training that describes yay transforms what optimizations are being made by the repo that implements the techniques I described in my last message. Okay, oh my god, this is so obnoxious. I want a better chat with PDF utility, so what should I do? Ideally, I would like to dump this file into Claude, but I haven't, Sam has my designated $20, not Anthropic, so if I just copy paste this whole fucking thing, let's do it, fuck it, right? Okay, let me hide that real quick, make sure I'm not leaking stuff. Okay. Are an expert. Okay. So. Wow, this is a long fucking paper, bro. Yeah, it would be way better to just dump this into Quad. Man, fuck, man. I don't want to pay $40 a month. I will miss my GPTs. But we have an open source version of the GPT store now. Homeboy finished that, by the way. So maybe I can finally stop suckling upon the teat. God, I need like a... I need the right chassis, bro. That's what I need. Okay. Distracted again, I know, but I have a plan, I think. This. Thinking. Doesn't Yohei have something that's just like way easier? We will wrap our heads around this, but do I want Instagraph or Graphlet? Let's see. Let's do Graphlet. Chat completion uses Quad 3 haiku. The fuck? I have no desire to do that. Gigs of storage. Okay, so just more of that plus usage. 10 cents per credit usage. Okay, I'm pretty sure I should have a Graphlet account already, but let's, in the meantime, let's just grab all the repos, and then what we will do. Okay, here's the plan. Here's the plan. Here's the plan, boys. Okay, step one, we are going to grab all of the repos and then we are going to clone them onto our machine with an NVIDIA GPU because I am poor and as such can only afford AMD machines. We are also going to fork all the repos while we do this. Then we are going to use Graphlet to start. Later on, we'll probably transition over to OpenSPG. But for now, we will use Graphlet just because we need something quick and dirty. And I think that's the best way for me to approach a long paper that's well beyond my depth. But I think if I structure it right, I can pretend to know math by making Claude understand all the explain all the equations to me. Maybe give him a Wolfram tool so he can actually run them and not start making shit up immediately, because that's my biggest problem I have with him. Anyway, so let's fork this. So, after we finish cloning everything, what we will do is we will grab a utility and we will turn the paper into a knowledge graph. Then we will chat with the knowledge graph. There's a couple of utilities that I'm going to use to do that. One is obviously Graphlet to make it, and then I might, if it is transferable, if it's like in a way that another system can interpret it, I might move it over into Neurite. But what we're gonna do is we're gonna go over to my repos here. Can RL, okay. So I outlined my plan. Plan is, let's make a knowledge graph with some assistance on it to help me understand all this fucking complicated shit. Not create link, huh? Interesting. Weird. Okay, so did I clone everything? So it's can RL was the last one. Then I need efficient. Okay. So now that all those are cloned, okay. From here, what do we need to do? From here, I think we need to start figuring out Graphlet. Maybe Storm will actually help me here. I'm gonna try it. I'm getting a lot of mileage out of Storm, honestly. If you're not familiar, it's one of Omar's things, DS Spy guy. Basically, it's just like a good implementation of DS Spy that like has a immediate application to lots of use cases. Kolmogorov. Kolm. K-O-L-M. Kolmogorov. I remember not being particularly impressed with Hyperwrite, but so what I'm doing right now is running through my existing tools and seeing if any of them can provide any helpful input as to which direction we should be starting off from.
Listen to that. Wouldn't you make a song written by a machine sound so beautiful, so beautiful? Of course. It's fine. A second. I think it's got up. That crashes on May 16th. Okay. I don't know if consensus can help with this, but we'll see. That's connected papers. Let's catalyze X. I don't think Semantic Scholar is going to help necessarily. Okay. Let's So I'm curious. Okay.
let me. Oh crap! I didn't have my the browser open the whole time. There we go. I'm gonna swap that over to Edge. Okay. So this is interesting. Interesting. So here is Storm's output. Okay, I really want to de-GPT this. I don't need innovative, I don't need revolutionize, like stop. Edges. Despite, yeah, okay. Hilbert's 13th, emerging from the superposition of univariate functions. Principle underlies. Okay, so we're decomposing. Cool. Oh my god, shut the fuck up. Interesting. Okay. So these are CUDA ops, right? Pure torch. And GraphCAN is just like interesting to me because I'm a slut for graphs. Okay. Well, I think I'm gonna call it here for now, and then maybe get back into it later, I think. Because I need to go eat lunch, and then I probably should give my brain a little bit of a rest, because I'm very dumb and trying to do math is hard. But I don't know, stay tuned for next time. This is actually a pretty solid few hours digging into it, so hopefully